Good evening, everyone. Myself Nitya. I am currently pursuing my engineering in Sri Venkateshwara College of Engineering, Bangalore. Today, I am here to discuss about the computer graphics and fundamentals of image processing. In that, the third program is apply geometric transformation on one 3D objects, keeping the second object undisturbed. Let's see the program. Import numpy as np, where numpy is imported as np, which is a library for numerical computations, where matplotlib.py plot is imported as plt, which is a plotting library, where mpl toolkits.mpl MPLOT 3D is imported to enable the 3D plotting capabilities in the Matplotlib. A function named as the apply transformation is defined to apply a transformation to the vertices of an object, with where transformation matrix is the matrix used for the transformation, where np dot computes the dot product of the transformation matrix and the transpose of the vertices matrix, where T transposes the result back to the original shape. The function returns the transformed vertices. Next, next to two 3D objects are defined by their vertices, that is object 1 and object 2, or numpy arrays, where each row represents xyz coordinates of a vertices, where angle is equals to np dot radians 45, which converts 45 degree to the radians, since trigonometric functions in numpy use a radians, where rotation matrix is defined as 45-degree rotation around the z axis using the rotational matrix formula. Next, applying the transformation to the object 1, that is apply the transformation function is called with object 1 and rotation matrix as arguments, where it transforms the object 1, which stores the vertices of object 1 after applying the rotation, where fig is equals to plt dot figure. Fig means here figure is equals to plt dot figure, which creates a new figure. It is a function which creates a new figure, where ax is equals to fig dot add subplot bracket 111 projection is equals to 3D, where it adds a 3D subplot to the figure. It adds a 3D subplot for the figure, where ax dot scatter plots the vertices of each object. The original object 1 is plotted in the red with the label original object 1. The transformed object 1 is plotted in blue with the label transformation transformed object 1, where object 2 is plotted in the green with the label object 2, where x dot legend adds a legend to the plot to identify the objects, where plt dot show it displays the plot. This code effectively demonstrates how to apply a geometric transformation to one 3D object while leaving another undisturbed visual and results. Let's see how the code will execute and what the output will see the output. This is the program we have written in the VS Code in the Python language. As we said, let's execute this to get the output. This is the output, where this is a 3D object where which has a 2D image in it, where it has a second object which is undisturbed. This is a 3D object. In that, 2D object is present. This is the another output for 3D objects while keeping the second object which is undisturbed. These are the original objects, and this is the 3D object, where these points are the object second objects which is undisturbed in this 3D space, where original object 1 is in red color, where transformed object 1 which is in the blue color, and the object 2 which is in the green color, which these are all the objects which we are placed in the 3D space, that is 3D objects. We have seen the program and we have seen the output. Let's see the what is the summary of this program. First, we will import the libraries like numpy, that is numpy, for the numerical operations, where matplotlib for 3D plotting, and we define a transformation function, a function to apply a transformation matrix to the vertices of a 3D object, where it defines the 3D objects to create two 3D objects which represented by the vertices coordinates, where it creates a rotation matrix which define a matrix for a 45-degree rotation around the z axis, where it apply the transformation. We use the transformation function to rotate the first object. Next, we will visualize the objects, that is, plot the original and transformed objects using a matplotlib to visualize the transformation. The main point here is transformation function, which applies a matrix transformation to a object vertices, where rotation matrix, it defines the rotation around the z axis, where visualization, which uses matplotlib to plot and compare the original and transformed objects. The result is a visual representation which showing the original object, the transformed object, and an unchanged object in the 3D space. This is all about this program. Thank you.